Well, it turns out there's no solution for this equation. Let's see why. We know each of these denominators cannot equal 0, so x could not equal positive 3, and x could not equal negative 3. Remember, we don't want these fractions to be undefined. This number would make this denominator equal to 0, and this number would also make this denominator equal to 0 as well. This last denominator has factors of x plus 3 and x minus 3, so really we've already taken into account the numbers that x cannot be for it, since we solved these two equations already. If we factor this last denominator, we can see that the LCD would be x minus 3 times x plus 3. We know this since this is a factor of this denominator, and this is also a factor of this denominator. Next, we multiply each term by the LCD. We cancel the factors that appear in the numerators and in the denominators. We're left with 2 times x plus 3 for the first term, and negative 3 times x minus 3 for the second term. Our last term is just negative 12, since these factors reduce to 1. This is a linear equation that we're familiar with. We simply want to distribute this 2 and this negative 3 first, and then combine our like terms and solve for x. Positive 2x and negative 3x equals negative x, and positive 6 and positive 9 equals positive 15. Make sure you're careful on this distribution. We have negative 3 times negative 3, which equals positive 9. It's really easy to make that sort of mistake. I'm going to rewrite this equation up here. Then we subtract 15 from both sides to get negative x is equal to negative 3. If we multiply through by a negative 1, positive x would equal positive 3. But we want to be careful here. We know x equals 3 is an excluded value. It makes this denominator and this denominator equal to 0. So these fractions would be undefined. Since x equals 3 is an excluded value up here, we know that there's no solution. There's no real number that exists that can satisfy this equation.